let us start now. Yeah. Still so many students are absent. Anyway, let's start now. So if you remember, what are the things we have covered in the last class? We discuss about hold on. Sorry. Yeah. So we classified the engine based on the several parameters, and then we were discussing about four-stroke engine. And in the four-stroke engine, we are discussing about how the spark ignition four-stroke engine works. So we discussed in details, and there are some questions also that we kept for a time being, because we will address that problems, particularly the valve timing diagram, once this introduction part is over. So now let us move to the same kind of the descriptions for compression ignition engine. Okay. So in compression ignition engine, look this picture very carefully. My idea is to ask the difference between these two images. This is the four-stroke spark ignition engine, and this one is your four-stroke compression ignition engine. Can you tell me that where is the some difference geometrically that you can see? Can you see any geometrically difference between these two pictures? Look these images carefully. And then what is
the fuel injector is present in the intake manifold, but in here it's present in instead of the spark plug in place of
okay. That's
So
really
the
very good.
valves are vertical.
Okay, that's fine. That is also fine. Correct.
The shape of piston.
Shape of the piston. Yes. That's really very good. Okay. So valves, as per the valves is concerned, yeah, valves, it depends upon the in several engine geometry, whether it has to be vertical or it has to be inclined. So that is depends upon the engine to engine. But what is the two most important thing difference or important difference between this four-stroke spark ignition engine and the four-stroke compression ignition engine? You can also say it four-stroke diesel engine. Is the here if you can see that the four is the injector, and this injector is installed in the intake manifold, and the second is a spark plug, and that spark plug is installed in the cylinder head. That is the case of your spark ignition engine. But when we are coming to the diesel engine, four-stroke diesel engine, so there is nothing, any kind of the injector in the intake manifold here. Okay. And but there is some parts in the cylinder head. Now, what is that? Is it the spark plug, or can we say is something else? The part two.
Sir, fuel injector.
Okay. So yeah, correct. So it is a injector here. So if you compare these two pictures, then the fuel injector has been shifted from the intake manifold to the cylinder head. Obviously, both, it is not the same kind of the injector, because it is going to be a lot of difference. Then because here the fuel injection is taking place in the intake manifold, where the pressure, it is maximum going to be close to the atmospheric pressure, because it's the intake manifold. Also there will be throttle here. So the downstream to the throttle, the pressure will be lower than the atmospheric pressure. So even if the throttle is going to be 100% open, the pressure at the back pressure, you can say, that is the pressure environment in which the fuel injection is taking place, it is going to be the maximum up to atmospheric pressure. But here now you are injecting in the injector. If you see the tip of the injector, it is open to the combustion chamber. So the fuel injection is taking place directly inside the combustion chamber. So now depending upon when you are going to inject the fuel, the pressure inside the combustion chamber will be something else compared to the what intake manifold it has. So therefore, what I'm trying to say at this point, that the fuel injected at whatever we have discussed in the spark ignition engine is completely different from what we are right now seeing in the diesel engine. So as in the previous diagram, 10 is your intake cam, 10 is the exhaust cam, 1 is the intake cam, then second is your injector, third is the intake valve, fourth one exhaust valve, fifth is piston bowl, okay, 6 is the piston, 7 is the cylinder liner, 8 connecting rod, 9 is the crankshaft, then we have a TDC and PDC. That is what the nomenclature it is saying here. Now let us discuss about this one. The second difference, what is the most important difference also that you have observed, the shape of the piston, that we have also discussed in the when we were discussing about the parts of the different parts of the IC engine. The shape of the piston shape of the piston top in the spark ignition engine is almost flat. Okay, here it has an integrated shape. It's something else. Still, I'm holding it that why it has been different. We have also discussed that this statement is true in most of the cases. But I have already introduced one of the things that if in some of the advanced spark ignition engine where the fuel injection is going to be shifted from the intake manifold to the cylinder head, then in that conditions also the shape of the piston is not going to be the flat, even it is going to be have a very integrated shape, or you may say it is more integrated than the diesel engine. But as of now, we can say that in general the top of the piston in the spark ignition engine has a flat surface, whereas in the diesel engine it has a bowl in the piston crown. So now let us discuss that how the whole 4-stroke diesel engine works. Let me explain first of all. Listen carefully and then ask the questions too much. So it is a 4-stroke compression ignition engine or 4-stroke diesel engine. It is called compression ignition because there is no spark plug as it was in the gasoline engine to initiate the combustion. But in the compression ignition engine or in the diesel engine, the combustion is going to take place only because of the compression. It is going to be the compressed to such an extent that the pressure and temperature inside the combustion chamber will be too high, and then when the fuel is going to be injected, then the combustion is going to be takes place. So therefore we are calling it a compression ignition engine or the diesel engine. Since we are discussing about the 4-stroke compression ignition engine, so we have a intake stroke, compression stroke, expansion stroke or combustion stroke, and this one is your exhaust stroke. There is a lot of difference. Okay, so based on these discussions, what we are going to next discuss about the differences between the 4-stroke gasoline engine and 4-stroke diesel engine. So let us discuss very carefully. So during the intake stroke, when piston will move from the top dead center to the bottom dead center. Intake valve will be in the open condition. In fact, the intake valve, please unmute yourself. Okay. Sometimes it happens. So intake valve, it may even open before the pistons comes down from the TDC to the BDC. Okay. So during the intake stroke, the piston will move from the top dead center to the bottom dead center. Intake valve will be open in open condition, and it is the only air. Here is the very important. It is only the air will come into the combustion chamber from the intake manifold. So now here is the difference. As in the spark ignition engine, since the fuel injection was taking place in the intake manifold, so therefore in the intake stroke, it was a mixture of fuel and air was coming into the combustion chamber. But here in the diesel engine or in the compression ignition in CI engine, it is the only air comes into the combustion chamber. So very important here. And then piston reaches at the top, bottom dead center. Okay, even at that time, intake valve is not going to be closed, but intake valve will be remain in the open condition for the some time when piston will move from the bottom dead center to the top dead center, that is in the compression stroke for a small fraction of the time, or from a small fraction or a small crank angle. How much crank angle we will discuss later on. So during the compression stroke, the piston will move from the bottom dead center to the top dead center, and the air, that is only the air that is present in the combustion chamber, is going to be compressed. There is one parameter that is called compression ratio that have not introduced right now. The compression ratio, it is nothing but it is a total volume of the combustion chamber divided by the clearance volume. You already know what is the clearance volume, what is the total volume. Okay, there was three kinds of the volume we have already discussed: displacement volume, clearance volume, total volume. Total volume is the summation of the displacement volume plus clearance volume. So how I am defining the compression ratio? The compression ratio is the ratio of the total volume divided by the clearance volume. That is called compression ratio. That is represented by R. So the compression ratio of the diesel engine is very high. Compression ratio of the diesel engine is higher compared to the spark ignition engine, or we can say the range of the compression ratio of diesel engine can vary between 16 to, you can say, 24. Okay, whereas in the spark ignition engine, the range of the compression ratio varies from 6 to 12. That is what is the range. So since the compression ratio of the diesel engine is very high, so the pressure, the compression end pressure or temperature at the end, towards the end of compression stroke, will be also very high. There's another thing that I would like to discuss here itself, as we have already discussed, that in diesel engine there in the diesel engine there is no throttle plate in the intake manifold as it is in the spark ignition engine. So the air comes or air flows in the intake manifold without any restriction. So the intake manifold pressure the pressure, the intake manifold pressure, we can assume it is close to the atmospheric pressure if we are neglecting any sort of the losses. So there is, in that case, we can assume that during the beginning of the compression stroke, the pressure inside the compression chamber is 1 atmospheric pressure. If you know the compression ratio, let's suppose it is 17 and P1 is 1 bar, and then P2, we can find it out assuming that gamma is equal to 1.35. So if you find it out, then it will comes around something 40 to 45 bar. I don't know, I don't remember exactly, but if you can just check it. So having around 17 or 17.5 compression ratio, take gamma is equal to 1.3 or 1.35 and P1 is equal to 1, then you will find it out the end pressure. At the end of the compression stroke, the pressure and pressure is coming something around 45 bar. So now only, and the temperature you can also calculate it. So now you can see that at the end of the compression stroke, the pressure and the temperature of inside the combustion chamber will be very high. Second thing is that before piston reaches at the top dead center, before the fuel injection will take place through the injector. Now, what I'm saying that injection is taking place towards the end of compression stroke, where the pressure and temperature is very high. Therefore, the fuel injection pressure has to be also very high in order to this liquid fuel comes into the combustion chamber. The differential pressure has to be very high. The pressure inside the fuel injection pressure, if it is a mechanical fuel injector, that we will discuss more details about when we will discuss about the diesel engine combustion. But at this point, at least we can say that if it is a mechanical fuel injector, then the fuel injection pressure will be around 120 to 180 bar. Or if it is a very advanced kind of the fuel injection system that is called common rail direct injection, then the fuel injection pressure can vary in the range of around 250 bar to around 2000 bar in production diesel engine. Experimentally now it is assumed, or researchers have claimed, or industry has claimed that they have developed a fuel injection system where the fuel injection pressure can go even up to 2500 bar. So now you can assume, because fuel injection pressure is very, very important in the diesel engine. So towards the end of the compression stroke, the fuel is going to be injected through the fuel injector at very high pressure. It will be either single jet injector or it is a multiple jet injector. It all depends upon the several kind of depending upon the application of the engine, design of the engine, optimizations of the engine. But as far as the passenger cars is concerned, it is a multi-hole injector. Your injector will have maybe the 6-hole or the 8-hole, so 8 holes. So as soon as, but from as of now, what we can say only is very important for us, that as towards the end of the compression stroke, the fuel is going to be injected with the help of the fuel injector at very high pressure directly inside the combustion chamber. At that time, the pressure and temperature inside the combustion chamber will be very high. So injected fuel, the liquid fuel, is going to be atomized. What is the atomization? Atomization is the disintegration of the droplets into the disintegrations of the liquid into the small droplets. That is called atomization. So the fuel atomization is going to be takes place. It is going to be vaporized and mixed with the air, and it's finally going to be burned. And that is what the combustion stroke is going to be started. During the combustion, the pressure and temperature inside the combustion chamber is going to be very high, and it is going to push the piston downwards, and that is what is our useful work, or we can say it is a expansion work is going to be takes place. That is the combustion stroke, in which the piston is moving from the top dead center to the bottom dead center. Before piston reach at the top at the bottom dead center, at that point the exhaust valve is going to be open. When the piston is about to reach at the bottom dead center, the exhaust valve is going to be open. The partial exhaust product is going to be flashed out from the combustion chamber to the atmosphere, which is because of the differential pressure. And then the remaining of the exhaust product is going to be flashed out from the combustion chamber when exhaust stroke is going to be takes place, in which the piston is will move from the bottom dead center to the top dead center. When piston is about to reach at the top dead center, then the intake valve is going to be open, and your again the next cycle is going to be start. Here it's very important to note that in the gasoline engine, we have a spark plug to initiate the combustion, and then a definite flame will be traveled from the spark plug, and it will propagate across the combustion chamber, and it will consume the air fuel mixture. But in the diesel engine, the fuel is going to be injected towards the end of the compression stroke, and there are several physical phenomena is going to be takes place, like atomization, penetration of the fuel droplets, vaporizations of the fuel, and then mixing of the fuel with the air and forms the combustible mixture. So depending upon the air fuel mixture distribution inside the combustion chamber, there is a probability that combustion starts at several locations simultaneously inside the combustion chamber if the thermodynamic condition is conducive for the combustion. So the combustion in the diesel engine is much more complicated compared to your spark ignition engine. How it is complicated and what is the so many things is going we will discuss when we will discuss about details about the spark ignition combustion and CI combustion. Now here what is the important thing is not that the air fuel mixing is very important in the diesel engine. In the spark ignition engine, the fuel has been injected in the beginning, or it is a mixture of fuel and air. It is coming inside the combustion chamber, and fuel has enough time during the complete intake cycle, and the most of the compression stroke has a lot of, so the fuel and air has a lot of time to mix with each other and form a homogeneous, almost homogeneous air fuel mixture inside the combustion chamber at the time of the combustion. But in the diesel engine, where the fuel injects, it is the only air that is coming inside the combustion chamber during the intake stroke, and fuel is injected to at the end of the compression stroke. It has a it has almost no time, or that it's a very small time, very small time to mix with each other. So here the air fuel mixture distribution inside the combustion chamber is varying a lot. It is not a homogeneous mixture, and therefore the compression ignition combustion or diesel engine combustion, it is also called heterogeneous combustion, whereas the spark ignition combustion is called homogeneous combustion. It is only because the air and fuel mixture forms a homogeneous mixture inside the combustion chamber in the gasoline engine, whereas in the diesel engine, The air fuel mixture is heterogeneous. There's heterogeneity in the nature in the air fuel mixing. So it's the biggest job when you are designing a diesel engine is the one of the most important criteria in designing the diesel engine is to how to improve the air fuel mixture homogeneity in the diesel engine, and so that we can have a better combustion and better drivability also. So that's the reason, one of the reason that we have a very integrated kind of the shape of the piston, so that it will generate a very specific kind of the motion, the swivel motion or tumbling motion of the air inside the combustion chamber that will enhance the air fuel mixing character. So that's the reason it has a, however, generating the swivel or tumble, it is not the only the responsibility of the design of the piston, it has a responsibility of the design of the intake manifold, intake valve, overall the combustion geometry. So these are, that's the way the 4-stroke compression ignition engine works. I'm sure you have some questions here. You may ask, please.
So how does
Any
the
question
shape
here?
of, so can you hear me?
Yeah, please.
Okay, so how does the shape of the piston head facilitate better mixing of the air fuel mixture?
Yeah. So as I'm telling you that since the air fuel mixture distribution is is heterogeneous in nature, so the design of the designer of the design parameter of the diesel engine should be such that we can improve the homogeneity of the air fuel mixture. So how it can be improved? There are two ways that we can improve it, or we have to utilize the both options. One is to do something with the fuel injection parameter. Okay, and the second thing is that create X motion of the air inside the combustion chamber, a certain kind of the motion inside the combustion chamber. Okay, these are the two ways. Here we can have more fuel injection pressure, okay, or we can have a multiple fuel injection per cycle. In that way, we can improve the homogeneity of the air fuel mixture with taking the consideration of the fuel injector parameter. And the second thing is that with the designing of the intake manifold, intake valve in such a way, and the piston geometry, that as the compression stroke is going on, there must be a certain kind of the motion flow direction, and the flow of the direction must be there. A very vigorous kind of the motion of the air should be there, so that it can carry the fuel and take it in all over the combustion chamber, and it will enhance the combustion chamber. So to create a special kind of the motion, either it is a swivel motion or the tumbling kind of the motion, it depends upon the geometry of the intake manifold, intake valve, and your piston geometry. That's the way it is going to help it to create the special motion or vigorous kind of the motion inside the combustion chamber. So by using these two methodology, we can improve the air fuel homogeneity level, and therefore the design of the shape of the combustion chamber in the diesel engine itself is a separate research topic, that how we can design the combustion chamber so that the motion of the air can be created in such a way that it can transport the fuels from one place to the another place, so that the fuel can be spread all over the combustion chamber. Okay, next question. Anything? Okay, so with this description and our the description of the previous class, now how we can, if now the question is, if you have to tell us, tell that what is the difference between the 4-stroke spark ignition engine and the 4-stroke compression ignition engine, then what you can say? Can you tell me some of the differences between 4-stroke spark ignition engine and 4-stroke CI engine? Any difference?
Yes, sir. Sir, in case of the
Yeah.
spark ignition engine, the fuel injector is in the intake manifold, and it is a pre-process that both the air and the fuel gets into the combustion chamber. It happens before the compression stroke, and the time for mixture to get homogeneous more to attain the process of homogeneity is more. But in case of the compression ignition engine, first of all, there is no fuel injector outside this intake. I mean, outside the combustion chamber, and it is inside. Moreover, and the process of becoming more homogeneous to attain homogeneity is less. I mean, the time for attaining homogeneity is less.
Very
And
good.
the second
Very,
point of difference is this
just
piston
hold on,
shape.
Siddhartha. Let us get the, yeah. So let us go to the another students. That's fine. Siddhartha is very good. Now he has explained it very nicely that based on the fuel injection, okay, there is a difference between 4-stroke SI and 4-stroke CI engine, and that's the way he has explained very nicely that there's a difference between these two based on the fuel injection parameter or fuel injection process. That's right. Very good. Somebody else, please come forward. And
Sir,
some other
sir,
differences.
hello.
Yeah.
Sir, ignition
Yeah,
in
please go
the
ahead.
SI engine is done by the spark plug, and the ignition in the combustion engine is done by the massive pressure buildup. There's no spark plug needed in the combustion engine.
Okay, Pulkit, that's really very good. Okay, the main, yes, yes, yes. So Pulkit is telling that both the engine can be can be differentiated based on the ignition methodology. A spark plug is the responsible to initiate the combustion um, in SI engine. SI, it means a spark ignition engine. Whereas in the CI engine, that is compression ignition engine, it is the responsibility to initiate the fuel injector has the responsibility to initiate the combustion. See, the thing is, when towards the end of the compression stroke, when the fuel injection is taking place, at that time the pressure and temperature is very high, and the combustion is going to be start after just some delay. That delay is called ignition delay. However, just hold it right now. Okay, so we can assume as of now that the fuel injection or the initiation of the combustion in the CI engine takes place as soon as the fuel injection takes place. So as of now, we can say the spark plug is the responsible to initiate the combustion in SI engine, whereas the fuel injection is the responsible to initiate the combustion in CI engine. Okay, very good. So the based on the fuel injection methodology, based on the ignition methodology, you have a differentiated between these two kind of the engine. What else we can say? Any sort of the difference?
Sir, the number of control lines on the piston are different.
Number of control lines. Can you explain a little bit more, Samir?
Uh, The lining on the piston in the SI engine is less. I mean, only two lines are there, but in diesel engine, there are more lines.
More lines, I'm not getting what you are saying.
I don't know the term that you use.
This which lines you are saying? This and the piston and here in the line, here in the lines, or something else?
So those only, the three lines that are visible.
Here, this one is same. So this is. Can you tell me that what it is representing? These lines?
I don't remember the term.
Okay, it is a piston ring.
Oh yeah.
Okay, it is these things is representing the piston ring. So what you're saying, the piston
Number
ring,
of piston rings are different.
But you can find it out that two or three piston rings or two piston rings in the SI engine and two piston in the CI engine also. There is nothing, it's a kind of differentiations that based on the piston rings we can make it that how it is different, the 4-stroke CI and the 4-stroke SI engine.
Okay.
Yeah. Think else, something else. One difference that you can tell that you guys has tell me the day one that what is the difference between the diesel and gasoline engine based on the fuel. What you can say based on the fuel? How can you can differentiate the CI and SI engine based on the fuel? Here, if we have to differentiate the SI and CI engine, okay, 4-stroke CI and SI engine. So based on the basic cycle that we have not discussed right now, okay, that we will discuss. But I am hoping that in your thermodynamics, you have at least gone through that SI engine works on the principle of Otto cycle and the CI engine is based on the diesel cycle. Details little bit we will also cover it. So based on the cycle itself, you can differentiate the spark ignition engine, 4-stroke spark ignition engine and 4-stroke CI engine, compression ignition engine. SI engine based on the Otto cycle, a CI engine based on the diesel engine. That is the one difference. That is the very basic difference that you can say. Based on the fuel, okay, in SI engine gasoline is used, in CI engine diesel fuel is used. Can you tell me some other fuels that can be suitable for SI engine? What you can say apart from the gasoline, which fuel can be used for a spark ignition engine also? Tell me. I hope some of you have experience also. You have seen already.
So kerosene.
Kerosene, okay. What else? That in your you are seeing in the daily life even nowadays.
CNG.
CNG, yes. Why you are hesitating? Tell me the count CNG. CNG in most of the cities in India now is currently in used, and it is a spark ignition engine. Can you tell me the any other fuels apart from the diesel for the CI engine? apart from the diesel, can you tell me the name of the fuel that is used in CI engine?
So I googled and found out some DME fuel,
DME. Okay, that's very good. What is DME?
dimethyl ether.
Dimethyl ether. Okay, that's fine. Very good. And okay, but that is very specific kind of the fuel. It has a very good quality. Okay, because there is no carbon to carbon bond in the DME. So the DME is considered as a soot less combustion. What is the soot less combustion? That's hold it for right now. Okay. Something else that is not you need to know, take the help of the Google, but based on the general knowledge, what you can say, something else. Probably you have gone through the so many times in the newspaper or in any times in any discussion. Something called, yeah, somebody's telling.
LPG.
What is?
LPG.
LPG. Okay. So what do you think? LPG currently where it is being used? It is used for CI engine or it is used for the SI engine?
Like in households, it requires some ignition point. SI
Mm-hmm. Mm-hmm.
spark is required, but there are
Mm-hmm.
accidents related to LPG. Yes.
No, just leave it about that. I'm just talking about your daily life experience. Okay. What do you think? LPG is used for SI engine or diesel engine? What have you seen that LPG? I'm sure that you have seen the LPG cylinder is used in the engine. Have you tried to find it out whether such kind of the engine is SI engine or this CI engine?
Sir, SI engine, petrol.
It is a SI engine. Yeah. Right now, see, I'm not. I don't want to go in much details. Right now, I'm just trying to find it out. Some of the very basic kind of the questions that you are seeing that probably you can see in your daily life itself. Apart from that, I hope that you may have heard the term biodiesel somewhere in the news or biodiesel. That is also is a very promising kind of the fuels for the SI engine. Obviously, it is not being currently used in the mass production, but it has a better future. Let us see. So based on the fuel, we can differentiate the SI and CI engine. One of your friend has explained very nicely about the introduction of the fuel. Induction of the fuel, we can differentiate that in SI engine, the fuel induction is taking place into the intake manifold, while in the CI engine, the fuel is injected directly inside the combustion chamber. Okay. Somebody can, if somebody can ask that, are you sure that in SI engine, the fuel injection is always taking place in the intake manifold? Then you need to consider, or you need to say that it is not always, but it is a general. But in a special kind of the SI engine, as I told you, the GDI gasoline direct injection engine, where the gasoline also injected directly inside the combustion chamber, just like a CI engine. What about the terms I'm using right now? GDI, PFI, CRDI. You can write down, and obviously I will cover all the things details in the later on. But you can also just Google it. What is, and just one or two three sentences. I'm sure that one or two three lines will be sufficient for you to understand what is this basic terminology. So in general, we can say that in SI engine, the fuel injection takes place in the intake manifold, and in CI, the fuel injection is taking place directly inside the combustion chamber. Based on the ignition, yes, the spark plug is used to initiate the combustion in SI engine, and the fuel injector is used to initiate the combustion in CI engine. Compression ratio. I have just introduced the term compression ratio, but still I am holding it when I will discuss about the engine some of the parameters. Then we will discuss in details about the compression ratio. For as of now, please take it like that. That compression ratio of the SI engine is less than the CI engine. The range of the compression ratio in the spark ignition can vary from 6 to 12, whereas in CI engine, the range of the compression ratio can vary from 16 to 24, you can say. Yes. So that's the difference between the difference between the 4-stroke CI and SI engine based on the compression ratio. Load control. What does it mean, load control? How we can differentiate the 4-stroke SI and CI based on the load control? Whatever we have discussed till now, I think based on that, you are in the positions to tell me that what is the how we can differentiate the SI and CI engine based on the load control.
Sir, what do you mean by load control?
Yeah, how we can generate more power. Which parameter we control in order to generate the more power in SI and CI engine. That is what is meaning the load control. It is based on your throttle. Okay, I have explained you in details that the throttle, what is the function of the throttle or accelerator pedal, accelerator. What is how the accelerates, when you are pressing the accelerator, then how the speed or the load of the engine changes with the SI and CI engine. So that is what you have to take the help from there in order to find and differentiate the 4-stroke SI and CI engine based on the load control methodology. So in SI engine, when we press the accelerator, then what actually happens? In SI engine, when we press the accelerator, okay, so the accelerator is what accelerator is actually doing, what it is actuating some parameter when we press the accelerator in a SI engine, which part or how the engine speed or the load is increasing if you press the accelerator in the SI engine.
And the speed of rotation of crankshaft.
Yeah, how it is increasing? Because when you are pressing the accelerator, what actually happens, as I have discussed 2-3 times, that the in fact what it is going to do, it is going to open the throttle plate. Okay, so accordingly, and you are going to inject the fuel. So it means in SI engine, it is a throttle plate, okay, through which we are controlling the load control, or we are controlling the mixture of fuel and air. We are controlling the mixture of fuel and air both in order to generate the load in SI engine. Whereas in the CI engine, there is no throttle plate in the intake manifold. We don't regulate the flow of air. So in diesel engine or in CI engine, when we press the accelerator, we directly control the amount of the fuel that has to be injected directly inside the combustion chamber. So it is the only fuel quality control. We only control the fuel quantity of the fuel in CI engine to control the load, whereas in SI engine, we control the mixture of fuel and air, both. So that's the difference between the 4-stroke SI and CI engine in order to control the load. As far as the weight is concerned, normally the weight of the SI engine or SI engine is lighter compared to your diesel engine, because the diesel engine has a higher compression ratio, and it produces more power. It is slightly bulky than the SI engine. So these are the some of the parameters. Okay, based on that, you can differentiate the 4-stroke SI and CI engine. I would say all these things you must, it should be always on, it should always be in the positions to tell what is the difference, because wherever you go, and if the interview or whatever, these are some of the things that probably the interviewer is going to initiate your discussion. And if if you are not in the positions to give the correct answer even at this very basic levels, then obviously probably they will change either the topic of the discussions or something else. So these are the small but very fundamental kind of the differences that everyone should be remember, or it should not remember. It should be, it's like you should know all these things. Okay, so is there any question here? So 4-stroke SI engine and 4-stroke CI engine, we have discussed how the 4 cycles, in what are the different kind of the activities or is going on in each stroke cycles, how the spark ignition engine works, how the 4-stroke diesel engine works, what is the difference between these two, that we have discussed till now. The next thing what we are going to discuss now today, in fact, about the 2-stroke. The way we have discussed the 4-stroke, that in which we need to have a 4-stroke of the piston or 2 revolution of the crankshaft in order to complete the 1 cycle. The similar way we are going to study about the 2-stroke engine, in which it needs only 2 stroke of the piston to complete the 1 cycle, or 1 revolution of the crankshaft will be required to complete the 1 cycle. So that we will discuss now about the 2-stroke engine, and then we will differentiate between the 4-stroke and 2-stroke engine. And then that's the way we are going to close the first initial part about the introduction of the SI engine, introduction of the engine, and then we will move on the parameters, the way some of the parameters, and then the basic cycles. Okay, so do you have any question here? Then you please ask, otherwise we can stop the session here itself.
Excuse me, sir.
Yes, please.